Hi everyone, in this video we're going to learn how Docker containers communicate with each other using Docker networks. We'll understand concepts like bridge networks, localhost, and internal container communication using hands-on examples step by step. Networking is one of the most important parts of working with containers because applications often need to communicate with databases, APIs, and other services. So today, we'll explore how Docker makes that communication possible. Let's get started. Docker automatically creates different types of networks. Here we can see the default bridge network created by Docker. Bridge networks allow containers connected to the same network to communicate with each other internally. Now let's create our own custom Docker network. This network will allow our containers to communicate using internal Docker networking and container names. Now let's run our first container connected to the custom Docker network. Here we are using several important Docker flags. First, the -d flag runs the container in detached mode, meaning it runs in the background. Next, the -i and -t flags allow interactive terminal access when needed. Then, we use the --name flag to assign a custom name to the container. In this case, the container name is nginx-container. This is important because Docker containers inside the same network can communicate using their container names. Next, we use the --network flag to connect the container to our custom Docker network called mynetwork. And finally, nginx is the Docker image we want to run. Now we are starting another container connected to the same Docker network. Because both containers are inside the same network, Docker allows them to communicate internally. Inside this Ubuntu container, the ping utility is not installed by default. So first, we need to update the package list using apt-update. This command downloads information about the available packages from the Ubuntu repositories, and next, we install the ping utility using apt-install. The iputils ping package contains the ping command we need to test communication between containers. The -y flag automatically accepts the installation prompts. Now let's test communication between the containers. Notice that we are using the container name instead of an IP address. Docker automatically provides internal DNS resolution for containers connected to the same network. So inside this Docker network, nginx container works like a hostname. And as we can see, the ping command is successful, which means both containers can communicate with each other correctly through the Docker network. Inside a container, localhost refers only to the container itself. It does not automatically refer to other containers or to the host machine. That is why Docker networks are necessary for container-to-container communication. Using Docker Network Inspect, we can see detailed information about the Docker network. Here we can see the connected containers, their internal IP addresses, and the network configuration managed by Docker. This helps us understand how Docker handles internal container communication automatically. Now let's see what happens when a container is not connected to the same Docker network. This time, we are creating a completely separate Ubuntu container without attaching it to my network. Before testing the connection, we first need to install the ping utility inside the container. So let's update the package list using apt-update, and next, let's install the ping utility using apt-install iputils-ping. Now that ping is installed, let's try to communicate with nginx container again. Because this container is outside the custom Docker network, it does not know how to communicate with nginx container. As we can see, the request fails. Docker cannot resolve the container name because both containers are not part of the same network. This demonstrates why Docker networks are necessary for container-to-container communication. Before we finish, let's quickly visualize how Docker networking works internally. Here we can see multiple containers connected to the same Docker bridge network. Each container receives its own internal IP address, but Docker also allows containers to communicate using their container names. That's why our Ubuntu container was able to communicate directly with nginx container. We also learned that localhost inside a container refers only to the container itself, not to other containers. And finally, We saw that containers outside the same Docker network cannot communicate with each other automatically. Docker handles all this networking internally, making container communication simple and efficient. And that's it for this tutorial. Today we learned how Docker networks work and how containers communicate with each other inside the same network. We explored concepts like bridge networks, localhost, internal DNS resolution, and container-to-container communication using real hands-on examples. We also saw that containers connected to the same Docker network can communicate using their container names, while containers outside the network cannot communicate automatically. These networking concepts are extremely important when working with modern applications, microservices, and Kubernetes environments. Thanks for watching, and see you in the next video.